This is solving for problem 26, A and B. Find the exact value of each trigonometric function of an angle theta if 3, -2 is a point on its terminal side. So before we get into A and B, the first thing to make note of is the 3, -2. What you want to make note of is 3, -2 is an x and y coordinate, and one thing that helps me move along in these problems is when I draw a plane and a triangle, the cosine is always here and sine is always here. So one way to think of cosine is always with the x-axis and sine is always with the y-axis here. So you can take that and apply it and assume cosine sine are the same thing. So using that, you can apply it to the 3, -2. So draw another plane. Cosine is 3, so here's a line here, and sine is -2, so drop down into the fourth quadrant, so -2, 3, and here's C, because we're going to have to use the formula a squared plus b squared equals c squared to solve for c. So a squared is 3 squared plus -2 squared equals c squared. After you do all the algebra, it'll be higher algebra 9 plus 4 equals c squared. C equals radical 13. So you can write that there if you would like. And now you can use this and apply it to both A and B. So A is asking for the cosine of theta. Now, one thing to remember before you move on is cosine is equal to the adjacent side over the hypotenuse. So basically, all you do is just plug it in. With this triangle, and compared to this angle, this is the angle for theta, the adjacent side is 3, and the hypotenuse is radical 13. And that essentially is your answer right there. If it's required that you can't have the radical, you can also just take the 3 radical 13, multiply it by whatever is here in the radical, multiply it by radical 13 over radical 13. You can do that because this is essentially equal to 1, but this will cancel out the radicals. Radical 13 times radical 13 is 13, and then this leaves you 3 radical 13. So either one works, depends on what's allowed on the exam. Okay, now we can just do that for B. B is the tangent of theta, and tangent is equal to the opposite side over the adjacent side, or you can think of it as sine over cosine. So you just go back to this triangle, opposite, -2, and adjacent, 3. And that is your answer, and that's how you solve 26A and B.